Okay, everybody. So let's continue. Yeah, it's recording.
Okay.
Got a blank scene file, and what we're gonna do first is draw the curve that the bats are gonna flow along. So I'm gonna press the curve tool at the very top of the shelf, and I'm gonna start laying down my curve. Let's zoom out quite a bit though, till we see like the 50 over here. Like we want a really long curve. Okay, so let's do something like that. Press enter or return. And I'm going to tumble around, and you can just kind of plop up your curve points like that. So it's kind of, in the end, looks like that. Bless you. Let me know if anyone needs help. So I drew it in top, like I kind of from the top, and then I like tumbled on the side, and I just pulled up the points. Okay, so dive inside of your curve and on the soft level. Some of you are already in there. I want you to select your curve, press P to get your parameters. The primitive type, I want you to change it to a NURBS curve. So it's nice and curvy and smooth. Next, we're going to resample. So tab, resample. And resample converts your NURBS curve into polygons and puts points equal distant, and I turn that on by just my point display right here. But you don't have to have it on, I just wanted to show you the points. So this is the curve that the particles are going to be flowing along. But we need a point of emission for the particles to be born, and then the curve is like a force that all the particles are being thrown towards. So there's a trick to finding the beginning of a curve. So if I put on my point numbers, sorry, that's the end. If I go all the way here, okay. You see how we have 1, 2, 3, you see that in my curve? You see my point numbers? 1, 0, 1, 2, 3. So what number is the beginning of our curve? What was that? 0! Yes, you're right. So what if I could do a delete, and I said 0, entity points, because we're dealing with points, actually let's do a simpler node. Sorry, I'm going to delete that. Let's do a blast. Tab blast. I'm going to put a 0, group type points. Delete non-selected. Delete non-selected. That's just inverse. I wish it would say delete inverse, but it doesn't. It says delete non-selected. So everything that's not 0, we're going to blast you away with this blast. See how it says not 0 down here? I am not 0. You get deleted. So what are we left with is the beginning of our curve. So now what we're going to do is copy a sphere on this point and use that as the emission for our particles. Yes?
Sorry, could you go over again how to just have it display the points?
Yes. I was just talking about how, do you see these numbers? 0, 1, 2, 3, 4?
No, how do I show those?
So these are just display, and they're on the right side here. Point and point number.
Okay.
So you can toggle those on and off whenever you want. They're just display. They don't do anything. They just show you information. Did you get to the blast node? Cool. Now we're going to copy a sphere. So we need a sphere. So tab, sphere. Space G to see your sphere. Primitive type, I'm going to say polygon. Then I'm going to put down a copy to points. I'll wait for you guys to catch up here. I just laid down some nodes. Got a sphere. I got a copy to points. It's kind of warm in here. Or is it me? Warm? Just gonna connect these guys, and I'm gonna come around to make sure everyone's okay. So I connect the sphere to the left and the blast to the right, and I'm just gonna template my curve so I can see both. Just like that. Okay, now I'm gonna make sure everyone's good. Oh my goodness. Okay, good. Yep. See? Yeah, that looks good. You don't have it templated, but I'm sure it's there. So that's because template your editor. Template your editor. Yeah, you're good. We had you displayed by on the top one.
Are you baby doing good? Yes. Mhm. Nothing really, because that's pretty much it. They're getting 24/7. Yeah, I'm home in Toronto and so are that was king. St. Patrick's. Okay. So pretty much definitely. Yeah, pretty much. Yeah, it's like as long as you have LinkedIn conversation, like you're active in the community, people will hit you up. It's like 3 years ago at the studio in Costa Mesa, they had, saying, hey, can you send us your portfolio? We're a VR company. Yeah. And they're like, okay, here you go. That's awesome. So we'll see if anything comes out of that. If like I wanted to just get like 3D animated like some videos, like Houdini and stuff, definitely helps, right? Yeah. Yeah, because you understand effects and animation. Part of art station. I haven't made one yet. What is it? It's just more or less like a website where you just push your work. Oh, okay. And then you go out and use different parts. Yeah, we're gonna do like character animation. Plug in animation, a 3D model.
Zero. Zero is the beginning.
The game jams that you work on. Just organize it the way you want. Just way of showing what you can do.
So, let's put down a pop net. Tab, pop, network. This is where our pops are gonna live. And what we can do, put your copy to points in the first input. That's gonna be the source of our particles. Let's put the resample in the second input. And right away we see something happen. If you zoom up there and you press play, you just see a bunch of particles that are starting to form a sphere. So let's go inside and take a look at what's happening. Particles are part of dynamics, so you can see right here where my mouse is, it says the word dynamics, so we're in a new context in Houdini. If you press tab, you'll see these are called DOPs, and you'll only see these in this context. So everything is context sensitive, so you won't see these DOPs in the SOPs context, for example. So when we look at the pop source, so this is kind of the typical setup in dynamics. You've got a solver, and all the solvers have like this cute little brain in the icon there. And you've got a pop object that really, you know, just kind of does initial stuff. Like all the bounce and friction and things like that would be here. We're not really going to use the pop object. It's the source that we care about. So let's take a look at the source. We have scatter onto surfaces as what's happening right now. And if we had points instead of geometry, we'd have the emission type be points, but we're starting with a ball, so we're going to say scatter onto surfaces. Then we've got the birth tab. We have impulse activation, impulse count, constant activation, birth rate. Impulse and constant. Constant means these number of particles per second. Impulse is by each time Houdini cooks, and that's traditionally like, you know, every frame or subframe, depending on how fast Houdini is, or how many sub-steps you've defined. So if you want like a burst of particles on like frame 1, you would do impulse. That's what we're about to do. We want a burst of particles. Typically when you want bursts of particles, you use impulse. Constant is when you want a constant stream, and it's by the time, by second. Activation just means on or off. So we're going to turn activation, constant activation off. So we don't want this like kind of faucet or of particles that are just running endlessly. We want a single burst of particles, so we want impulse activation on. And this is, if we have bats, then we're going to be like, okay, how many bats do I want? I want 30 bats, or something like that, around that. I want 30 bats to be born. But the thing is, they're still being born. Impulse activation is constantly on, so I'm getting these bursts happen all the time. I want impulse activation to be true only on frame 1. And as soon as we get to frame 2, I want my impulse activation to be turned off. So I get a burst, and then impulse activation is off. Okay? So we put $ uppercase F equals 1. And that way I get one burst of 30 particles, and that's it on frame 1. And they do nothing. There's no velocity on them yet or anything. They're just like born, and then they're just like frozen in space. Let me know if someone does not have what I have or can't see. Equals 1. Uppercase F. Very good.
That's not showing the.
Go to frame 1. Yeah, sometimes not so frame 1. Okay. Let's see. You can add to inherited velocity. Inherited velocity means any kind of velocity that we had, any velocity attribute that we might have put on our particles. We didn't put any on our particles, but actually I've got all my variance. So you have velocity and you've got variance. Variance is like spread. But let's still take that to 0. So still nothing is going to happen. We're actually going to add velocity next in another node. So actually, but I just want to make sure you know it's there. Velocity and variance are here. Birth, let's go back to birthing. And let's say the life expectancy, actually we can keep that. That's 100 seconds. It's life in seconds. How long will the particles live? Okay. Yeah. So now let's set up the curve, and the curve is going to be our velocity. So what we want to do is put in tab pop curve force. Pop curve force. And by the way, one thing is this geometry source on the pop source, it says use first context geometry. What that means is use the first input, because you've got use first, use second, use third, use fourth. Those are all inputs. For the pop curve force, we're going to say use second context geometry, because our curve is going into the second input of our pop force. And we see the guides. And now, if you want to turn off the guides or change the spacing, or just show a curve, and then that way when you press play, now my particles are following this curve, and I'm going to increase my timeline at the bottom. I go all the way to the bottom right. Global animation options, all the way, this button all the way to the bottom right. Just going to put another 0 for the end. And then I can just let it play and then come around. Let's see what's going on. All good? Yeah. Just scale your curve. That's cool though. Scale your curve. That's why I drew my curve. If you if you look at the scale of this thing, my curve is going from positive to negative 50 on the grid, on the main grid. So if you feel like your curve is too short, make it longer. You just put a transform. You just take one end of it and stretch it. However you're doing. So your curve isn't being brought in. So let's look at the curve force. This is happening here. And then we're going to say stop. So stop. No. Second. Because it's coming into the second input of your pop. See? Right here, I'll show you. Second input. Snap. Now go inside of your top net. Yeah. And now press play. Excellent. And then you want to extend your timelines probably. You did yours. But here it's just right there. save my file. And then give it to you. You're number 1. And then I think you have to accept it. There you go. Okay, so this pop curve force, it's a pretty big node. You could spend a lot of time with it. So air resistance, let's bring, in dynamics, the best thing to do is to change one thing, see what happens. Change another thing, see what happens. So I increased my air resistance, and that should, it's how much particles are to be influenced by the wind. So a bigger number should give you, actually, even though it doesn't sound like it, it should give you more force. So sometimes you can push these numbers really high just to see if they're working or not. But I've got that at 4. Max influence radius. The max influence, that's what this circle is. This sphere, this like tube that develops here. This tube is the max influence radius. So if I say make my max 7, it gets larger. And we're gonna talk more about what that means in a second for the forces. Okay, I'm gonna take that back to show curve only so that I can actually see my particles. Okay, next, follow scale. This is how much are we going to follow. Now it goes even faster. The follow scale is just like, it really pushes the particles faster along the curve. And if you put your mouse over the name, it'll explain. The amount of force to apply to the particles which will push along the length of the curve in the direction it was drawn. Negative values will make it go the opposite way. Suction scale is from the max radius to the curve. Is how much suction do you want it to have? So play with that. Orbit scale, I don't really want orbit scale, to be honest, because if I'm having like a flock of bats, they're not going to be orbiting around anything, but I might want to give it a tiny bit. There. So then that really gets them to a line. So then I'm gonna decrease my suction scale now, because I've decreased my orbiting scales. All these forces kind of do a dance with each other. So maybe I need to increase my orbit just to kind of and maybe decrease my follow scale a little bit. Unless what you want is a line. Okay, so then down below, so all of these fall-offs are like gradients from the curve to the max radius. So imagine that this area of the ramp is where the curve is, and this area right here is where the top of the max radius is, right here. So this is the core. This is the core of the tube, and this is the surface of the tube over here. So all of these have these like fall off. So when it gets to the max radius, the forces get weaker. So what would happen if you played with these guys? So here it's like the suction is higher at the surface, and the orbit is higher at the core. So they have these opposing areas. It's starting to look a little better. There's something else though. If I take my guide back, you could see the max radius. There's something called shaping here, and I can actually shape my max radius so that it changes in some places. And that's also going to change the forces along your curve. So that's under shaping. And I can take my grid spacing up here. These are the individual forces. Okay, so these are individual forces, and then the global forces. And this is force along length. So the force along length means that, you see how it's black at the end? It means that at the end, get rid of all the forces on the curve, because we want to set our particles free, and they'll just kind of carry the momentum. But if I were to change that, and now the bottom is red, the particles should get stuck at the end. Yeah. So they get kind of trapped at the end. So you can set them free. And then you've got one last multiplier that acts as a force multiplier on all the forces. So lots going on here. Okay, so hopefully everyone has something they're kind of happy with. Yeah. Oh, good. Cool. Cool. And if you wanted to do like a motion graphics effect where things are like exactly, you know, you could do something where they're like on that line by just tweaking, getting rid of all orbit and just like high suction, getting rid of orbit, they'd like follow that curve exactly, right? Kind of going off.
Yeah.
Don't worry about that one. Go to your individual. Maybe bring up your fall scale to 6. And I'll see what happens. How are they doing that? There's no velocity on here, right? Yeah, we're good. Oh, treat as length, that's off. And then there. Okay. Awesome. guys, let's put some bats on these guys. Okay, just like before, we're gonna bring this in. So tab null. We're gonna say particles underscore out. Particles out, we're putting that null on. And I'm gonna call this object particles as well. Okay, geometry. It's a new geometry mode. Tab geo, empty geometry container. Brand new guy. I'm gonna name him bats. Go inside. This time we need the file, and I'm gonna say P to bring up my parameters. And I'm gonna get in my geo, go to bats, and again there's another geo folder for some reason, but what I want is bats to center, or bats. Wait 1 second. Bat to center. Oh, it's funny. Well, I'm sure they're all the same. I'll try bats 3 center. Okay. So I've got this sequence of animation. It's a BGO sequence, but it might as well just be an OBJ sequence. It doesn't matter. It's just a sequence, a mesh sequence that has an order to it. This time, remember, this time we want to say show sequences as one entry and pick the sequence. So we're actually selecting the sequence, and you can see that we've got $F there. See that $F right there? So it knows it's like bat 3 center 1, bat 3 center 2, bat 3 center 3. It looks at your playback down here. So I want to make sure everyone has their bats in there. Go to frame 1 if you don't see it. So I'm going to go inside the distribute, go inside, and then click on that file node. 3 center. You guys are good? Yeah. Okay, so we're on frame 1. We see our bat 1. We go to the next frame, frame 2. It still reads it. We've got a bat 3 center 3. Now we're on frame 3, still reads it. 4 still reads it. 5 still reads it. 6 still reads it. 7, it's gone, and we have a big error because we don't have. That's the end of our sequence. It's over at frame 7. We need to figure out how to loop this file sequence, and we're actually going to do it in the file name. We're going to loop it, but before we do it, I got to explain something. I need to explain I need to explain a new concept called modulus. The modulus concept, I don't know if I'm spelling that right. I think it's, I don't know. That's either O or U. Modulus. And it's denoted by the percent symbol. And what the modulus does is it returns the remainder of division. And why is this useful? And I'm going to show you right now. So if we say $F mod 7. That's basically like we want to loop this thing every 7 frames. And how does this work? So if we say 7 into, if we're doing division and we're trying to get the remainder, 7 into $F. Okay, so let's work out the math, right? We have 7 into 0, 7 into 1, 7 into 2, 7 into 3, and we'll keep going. So 7 into 0 is 0. We got all these zeros, right? 7 into 1, still 0, 0. We got 1. 7 into 2, still 0, 0. We got 2. 3. Are we starting to see a pattern here? Look at the remainder. Okay, so I'm going to go up to 7 into 6. I'm going to skip a couple. Got 6. And then what happens when we get to 7? 7 into 7 is 1. Now, 7 minus 7 is 0. 7 into 8, we got 1. 7 into 1. Starts over again. So what you end up with is 0, 1, 2, 3. I'm going to dot, you know, up to 6. And then it starts over again. 0, 1, 2, 3, all the way to 6. You know, 4, 5, 6. I'll write it here, 4, 5, instead of being lazy. Do you see that pattern? 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6. That's what the modulus does. Pretty cool, right? It's pretty cool.
Yeah, cool.
No, it's not cool? Okay, we want to use this in the file frame. Now, expressions here's the thing: a file name is a string. Remember, we talked about file types. We talked data types. We talked about integers, floats, vectors, 3 floats, 4 floats. We've got a new data type. It's a string. We've got a string, but what we want to do is do some math, which is not a string. We want to write an expression, but we want the result to be dumped back onto a string. And Houdini has a way of doing this, and it's by putting backticks onto an expression. It gets protected, and then it evaluates, and everything, the resultant information gets written back onto the string. Okay, let's go back to Houdini, and we're gonna put our backtick. A backtick is right next to, it's right above your tab. That's a backtick. We already have our $F, and we want to say mod 7 backtick. Okay. Now let's play it. Now we get an error every time it goes to 0. So we actually don't, the values we get returned are 0 to 6. But we actually want 1 to 7. So what do we do to go from 0 to 6 to 1 to 7? Anyone take a wild guess? What was that? Not exactly. Anyone else can take a guess? What we need to do? From going to 0 to 6 to 1 to 7. Add 1! I heard it. I didn't get who said it, but I heard it. We add 1. That's right. We do, right after that 7, we add a 1. Plus 1. Okay, now, I'm still getting a dumb error. Because I don't have my that's 6. I might need to do mod 6 plus 1. This is a different, this one's different than the, yeah, it's actually mod 6 plus 1. This one is a weird file for some reason. Okay. F mod 6 plus 1, and all in the back takes it. Everyone got this? Now, if you want to see it in real time, press this little real time button right here. Okay, it's going to be fun the next couple notes. It's going to be fun. I did a lot. Because those words are quotes, not backticks, right? Gotta switch those up. I know they look really similar. Good job. You got yours? Yep. Good job, good job, good job. You guys got yours? Cool. Okay, color our bat whatever color you want. Just put a color node down there. Okay, now we're ready to copy onto points. We're like pros already with this, right? Copy to points. Tab. Anyone remember the node we need when we want to import one network into another? Object merge. Object merge. And let's get our object. Particles. Particles out. Hopefully all uppercase so that you can find it. And now you should have something that looks fabulous like this. Masterpiece. It's done. Just kidding. Just kidding. Okay. Let me just make sure everyone has this. Raise your hand if you do not have this. I will come around. Okay. I believe you. I totally believe you. Where's your display flag? And then space cheat. Down there with your mouse. What?
You guys good?
I know you did good things. I totally believe that you did good things. There's one thing you didn't do. Aha! See, you know what was getting you? It was this puppy right here. You gotta hide your other objects because they're fooling you.
Oh, okay.
Oh, look at that. See, in some cases, orbit looks pretty sweet. So when your orbit, you got your tight orbit like that. That's looking great. It's gonna look cool when we're done.
Right now it looks like nightmare fuel. But in a good way.
That looks like your nightmare.
Yeah.
Yes, I'm liking these different color bats on this row. Cool, cool. Yeah, there you go. Display flag. Display flag. Okay. What's wrong with this? So many things, right? Let's fix it. Okay, you guys are going to kill me. After all this work, there's a really easy node called attribute randomize that does a lot of the stuff that we slaved over earlier. But now you know what's really going on. Oh, I got different colors. Attribute randomize. Attribute randomize randomizes color by default. Don't really want to do that. P-scale. Remember what P-scale does? Now we've got some babies and mamas. Those are some really tiny little babies though. But look, it also has a fit. The min value and the max value. We can just take those, the min up. We could take the max down. So we can say, I don't know, 0.6 max and 0.2 min, maybe something like that. Or maybe 0.5 max, 0.1 min, 0.15 min, like that. There we go. It's starting, I feel like this is better. Okay, we still got a really big problem, right? All the wings are flapping at the same time. It's a big problem. Also, I'm jealous of all the colors, so I'm going to change my color. Actually, I'm gonna do something, one more thing, sorry. I'm gonna put, this is optional. You don't have to follow me, but if you want them to have different colors, because you're crazy like me, I'm putting a color node here on the point side, not this side, because what's the difference? If I put a color here, I'd have to like do a stamp function to get it going upstream this way on the geo. But if I do color on the point side going down, my geo will inherit it. It's different. It's really different on the right and the left. The right side is points, attributes on points. The geo inherits those attributes. So if I go here and I say, if I put down, if I put down a point attribute and I say, I'm gonna say custom. I'm gonna say colors for my new attribute that I'm totally making custom. And let me see that. Let me do it first to make sure it works. Colors float. I'm gonna say rand at ptnum. Then this guy is going to be ramp from attribute. Here I say colors. And now I get to choose from a ramp. I like that more. Now you guys are going to be jealous of my colors. So again, if anyone wants to do that, all I did was I made a point, custom attribute. I name it anything you want because it's your own attribute. And you're shoving this value, rand pt num, which does what? Scrambles each point number into a pseudo-random number between 0 and 1 and attaches it to each point. Take that value. Then what's happening here? It's like, because we've got randomness from 0 to 1, check this out. This is 0. And this is 1. So if my pseudo-random attribute is going to fall somewhere randomly on this ramp. I hope that makes sense. So now I'm going to make this like that, like that. Yeah, something like that. Okay. We passed Halloween, but you know, spirit is still alive. Now, okay, now let's get serious. Let's get those wings going. Time shift. Time shift. Now this is going to be a little bit of a mind bender. Okay, copy to points. You guys gotta have to forgive me. Wrong copy. We need a copy stamp because we need that stamping functionality, and I forget that sometimes. So delete the copy to points. We need a copy stamp. Stamp inputs. Don't forget to stamp your inputs. We're going to name our variable random wings. That value will do Okay, here's the thing with particles and the difference between particles and points. They're pretty much the same thing, except for one difference. If you've got points in SOPs, right? And one point gets deleted, that entire point cloud gets renamed. There can be no gaps in point numbers. Point numbers go from 0 to how many points you got. There can be no gaps. So if a point gets deleted, everything gets reshuffled, renumbered. In particles, if a particle dies, which is very common for a particle to die, because particles have life, right? Particle dies. You don't want those particle numbers to be reshuffled, to be renumbered. So there's another attribute called particle ID. Particle ID, there are gaps. They don't get renumbered. So when we deal with particles, we don't use PT_num, we use ID. But essentially, the concept is exactly the same. So we're going to use rand, open quote, at ID instead of PT_num to protect against death and renumbering. So who remembers the output range of a random function? What kind of values do we get? Bingo! For what we're about to do, though, you got the rainbow of death? Let me give you my file. Did you ever get my file? I'm going to give that to you again. Oh well. Doesn't seem to work. Did you get my file, Marcel? Or, sorry, Christian. Okay. The values that we want are not, we don't want 0 to 1 output range. What we want is like something like anywhere from 0 to 24. And I'll explain why in a second. But let's just get it ready right now. I want to multiply this by 24. Cool. Let me know if you want me to pause. Otherwise, I'm going to keep going. We've got this time shift. We've got a time shift. And what I'm doing with that time shift is I'm going to stamp the variable here. Okay. So we take this time shift that has $f, which does nothing, as we discussed earlier, and we're going to say stamp, open parenthesis, quote, dot dot forward slash, copy 1, close the quote, comma. I almost want to say chicken wings. Random wings. comma, 0. Close the parenthesis. Return. Oopsie. Ah. There we go. Still pretty cool function there. I like it more than the Windows magnifying glass. So awesome. No. But let's look at your copy. That's because your variables different than mine, but you can shift. Oh no. Oh wait, no, that is right. You just don't have your P scale set up. See your max values too? Should be it's a little high because they're like all on top of each other. Maybe like 6. Maybe when they fly, let's see, press play. They kind of get untangled. Is that how it works? Which is fine. They do get untangled then. We can always delete the beginning of their lives. You could still take them down further, like the P scale to like. Yeah. Get really small, like min 20. Yeah. Yeah.
Okay.
You know what I mean? That's gonna be more useful for us. Party time.
Where do you like, where do I put the copy? Is it under the attribute random?
You're basically swapping out these two guys.
Oh, okay.
So wherever, yeah, there you go. You get rid of it. Take off your points. Display flag on the copy. How are we doing over here? Yeah. Yeah, they're cruising. Now we've got a new problem, right? They all have different wingspan. Bonus credit. Anyone can guess what we need to add to this to get them to flap? Okay, so what did we do? What did we actually do with this stamping? Time shift, just like what it says, right? We shift in time. What did we do? We told each bat to randomly choose, you know, anywhere from 0 to 24, a different starting frame. So each of these bats is starting on a different frame, anywhere from 0 to 24. Because what is this variable doing here? Rand ID times 24. So remember how all this is doing, let me just open Photoshop really quick. So I'm bat 1, I'm bat 5. Not to be confused with decimals. So I'll just say number 1, number 5, bat. Okay. Now just simply rand ID is just going to give us, you know, like some decimal numbers that don't really do anything for us. I'm making those up. I don't really know what they mean for if you put them in the random. So like rand 1 gives you something, rand 5 gives you something. then remember we're timesing it by 24. So now when you do that, it's going to equal, I need a calculator to do that, but I think it's like, I'm just going to guess somewhere here. What's 24 times 0.2? Anybody? Say that again? 0.48? 24. Wait, I got a calculator right here. 24 times 0.35, 5.6. So let's just say, you know, it's gonna be like 5 or well, maybe it rounds up to 6. So this bat number 1 goes all the way to frame 6 because the time shift is shifting based on that stamp function that we put in there. It's saying, okay, you are going to shift to 6. Okay, then let's do the other guy. Sometimes in Houdini, you just got to work out the math and to like really get what's happening. So like, what's 0.478 times 24 equals 11. So this bat is going to shift to the starting frame of 11. You see what I'm saying? So all we've done so far is shift their starting point, and that now they're gliding like frozen, because that's all we've done. Now we need to add something. We need to add something that changes every frame. We need to add something that changes every frame. So we, at the very end of this, we say plus $ uppercase F, and now we're whole again. We're done. That's it. That was it. You just add $F. Do you guys get why that works? Was that a no or a yes? because 6 plus frame 1 is 7. 6 plus frame 2 is 8. 11 plus frame 1 is 12. 11 plus frame 2 is 13. Yeah. So as soon as you add that $F, the you know, it starts to roll again. You see what I'm saying? They were dead and now they're back to life. And now let's get a dramatic camera. It's time for their close-up. There we go. I mean, we could, the animation isn't that great, but it could be a little more elegant with the flapping. Okay, we finished the bats, particles. I'm gonna pause the recording. Let's take a tiny break and we're gonna come back and do snow.